Now we're just going to talk about how we would compare data sets. So in the lessons, it actually has this lesson before the interpreting data sets, so before what we just did in the last video, but I think it makes a little bit more sense to do it after, because once you can interpret data sets, then you can compare them. So what we're doing here is, instead of looking at one set of data, you're just looking at two sets of data side by side. So what we're going to use is the example on page 211, where they are comparing two different schools in this Springfield location. We've got school 1 and school 2, and they're comparing how many students ride each bus, where this first school has 8 buses and this other school has 10 buses. So what I'm going to do is I'm going to create a box plot for each of these. So I can easily find my maximum, minimum, median, first quartile, and third quartile by just putting it into my calculator. So I'm going to just do that really quickly. Once it's in my calculator, I can calculate the statistics, and I've got everything that I need to create a box plot right here. So I'm going to write down my minimum, which is 16, my maximum, which is 47, my median is 35, my first quartile is 18.5, and my third quartile is 39. So when I would create this box plot, what I'm going to do is I have room for my first school and my second school. So I'm going to create this box plot using that designated area. So I know my minimum for school number 1 is 16. I know my first quartile is 18.5. I know my median is 35. So we're all the way down here. I know my third quartile is 39. And my maximum is 47. So this is really spread out data. So if we were interpreting it on its own, we would be able to tell that there is a very large range from the median in the lower half, where the upper half is more condensed. So we're thinking about the fact that we've got way more of this higher number than the lower numbers, but our lower numbers are more varied. This is a very large span, from 16 students on a bus to 35 students on a bus. The other set of data, I can clear my calculator real quick and enter in the second set of data. We've got 29, 34, 22, 26, 26, 31, 22, 35, 27, 30. I'm going to calculate my single variable statistics and then put it on a graph. So now that we have those stats, I can see that my maximum is 35. My minimum is 22. My first quartile is 26. My median is 28. And my third quartile is 31. So what I'm going to do is put that onto this graph. So I have my minimum at 22, my Q1 at 26, my median at 28, my third quartile at 31, and my maximum at 35. So what we'll notice about this data is that it really does make sense that they have more buses, because each bus tends to carry less students, because these buses over here, we've got a large number of students on them and just a couple that have just a few students, where this one, yes, we have more buses, and on each of those buses, we've just got a few less kids. So what my interpretation would be is that for this first school, most of our kids live pretty close to each other, so we can fit more kids on less buses. Except for a couple of neighborhoods where we had the 16 students and 17 students, where this one, it seems like we're pretty well distributed, maybe into a few neighborhoods where we would have to send a bus into each neighborhood, why we have a few less kids per bus. But it allows us to have a pretty good visual at, comparing them and thinking about how their medians compare in their first quartile and their interquartile ranges. This one is significantly larger than this one. And so it just allows us to compare on the same scale. And that's why I like to use graph paper, because then I know my boxes are, closer to exact measurements rather than just sketching my own number line on a piece of lined paper.